Hello again, everyone. Today our goal is to learn how to sketch graphs of polynomial functions. So we're going to do a little background info first, some new vocabulary, and then we'll jump into sketching graphs of those functions. So first new vocab term we need to go over is end behavior. So end behavior is the value a function is approaching as x is approaching both positive and negative infinity. Depending on who you talk to, depending on what book you read, there's a couple of different ways that you can write end behaviors. For the purposes of our class, we're always going to write it the same way. So if we look at this first function here, f of x, we are looking at a quadratic, something we know about already, with a positive leading coefficient. And that's really the two pieces that we're going to be looking at. What's the degree of the polynomial? And then what's the sign of the leading coefficient? Between those two pieces of information, we'll be able to write out our end behavior. So for our end behavior, we want to know as x approaches negative infinity, our function is going to approach something. As x approaches positive infinity, f of x, again, will approach something. And we just have to figure out what that something is. So we have a little chart over to the right-hand side here that will help us out with that. So like I said before, we're going to be looking at the degree and we're going to be looking at the leading coefficient. So since here we're looking at a second degree polynomial with a positive leading coefficient, just like we would have anticipated anyways, we know really what our graph's going to look like. It's going to be rising to both the left and the right-hand side. So if we're talking about the extremes of our graph, if we're talking all the way out to negative infinity on the left-hand side, well, we know our function is going to be facing up. It's going to be approaching positive infinity. So I will be putting a positive infinity here. If I look at now the other side of my graph, my right-hand side, as x is approaching positive infinity, as x is getting increasingly larger, what's our function approaching? Well, again, it's going up forever and always. So because it's going up, it's going towards or approaching positive infinity. And that's the way we'll write the end behavior of that function. If we look down at our second example here, again, we need to look at the degree and the leading coefficient. Our degree here is 5 and our leading coefficient is negative. So 5 being an odd number, we're looking at an odd negative relationship. So we'll get to the graphs momentarily, but as of right now, this is really what our graph's going to be looking like. It's going to be going up to the left-hand side and then going down to the right-hand side. So we'll start our end behaviors written out the exact same way as before. As x approaches negative infinity, f of x approaches something. As x approaches positive infinity, and f of x approaches something. So like we said, towards the left-hand side of the graph, so as x is approaching negative infinity, our graph is going up forever and always. So again, our function itself is approaching a positive infinity. So we're looking at the y values. Our function is approaching positive infinity. As x is approaching positive infinity, now we're looking at the right-hand side of our graph, of which we can see that that's falling. So that is approaching negative infinity. Last example we're going to do, notice this one I did not put in standard form on purpose, so make sure that you're always just looking for the highest degree of the polynomial in standard form. Here it looks like we have a third degree polynomial, and if we look at the leading coefficient, that's that positive 3 there. So we're looking at stating now the end behavior of an odd function with a positive leading coefficient. So now we're going to be looking over here. It's an odd degree function and a positive leading coefficient. Again, I write out my end behaviors, same kind of way every time. I want to know as x approaches negative infinity, what my function is approaching. And as x approaches positive infinity, again, what does my function approach? All right. So since we're looking at an odd positive, we're going to be looking now at our graph over here. So you'll see that this is really the flip, if you will, of the odd negative. So if we're looking at the left-hand side of the graph first, always looking as x approaches negative infinity first. Our function we see is falling. It's going down on the left-hand side, excuse me. So that means that our function itself would be approaching negative infinity. And if now we turn to the right-hand side of our graph as x is approaching positive infinity, we see that our function is going up forever. So that means it's approaching positive infinity. So a little background in end behaviors. Now we turn to our second piece of vocabulary, which is multiplicities. So the multiplicities, by definition, is the number of times that a factor appears in a graph. So we've gone through factors and roots before. So if we're looking at this first factor, this first example here, the factor of x plus 3, we know occurs twice. So we can say that the multiplicity of the x plus 3 factor, so multiplicity is 2. Multiplicity is 2. G of x, it looks like we have a 1, a 2, a 3, 4 factors here. So the x has a multiplicity of 1. The x plus 7 has a multiplicity of 4. The x minus 4 factor, again, has a multiplicity of 1. The x minus 2 factor, again, has a multiplicity of 1. If we're looking here, if we refer back to end behaviors for a moment, if your function is in factored form like this, we have to add up all of our degrees of the factors. So if we were looking at this g of x function and we were asking about the end behaviors, we would need to add all these together. So we would have to add 1, 4, 1, and 1. We would be looking at a positive. The leading coefficient here is definitely positive. And then it's a 1, 5, 6, 7th degree polynomial. So just as a note too, since we're talking about multiplicities, refer back to end behaviors as well. We will be graphing momentarily, and we got to put both of those two pieces of our puzzle together. If we look at example number 3, we have a leading coefficient that's positive. If we're looking at each of our factors, we have an x minus 3 factor that occurs twice, so the multiplicity is 2. The x plus 5 factor occurs 3 times, its multiplicity is 3. The x minus 1 factor occurs once, so it has a multiplicity of 1. We're again looking at a positive leading coefficient, and if we total up all of our degrees here for each of the factors, we get that this function h of x is a 6th degree polynomial. All right, let's add in another piece now since we're talking about multiplicities. Each of the multiplicities that we've gone over so far interprets differently when we're sketching a graph. So I decided to look backwards first so that we can look and try to create a graph from, create a function from a graph. If we look at the graph here, we see that we have a root at -1, another one at 0, and another one at 2. So I'm just going to call this function y equals, because I don't really know its name. I'm going to rewrite each of these roots now with its corresponding factor. So my -1 root, I know, will translate into an x plus 1 factor. My 0 root translates into an x factor. If you want to put x plus 0, x minus 0, that's fine. And the last factor, the last root is 2, so that means the last factor is x minus 2. Now notice from here, what happens at each of those roots looks very different. This -1 here root, this is what we call a bounce. So a bounce occurs, it looks like the graph is coming down and then it literally is, it bounces right off whatever axis it hits and then pops back up in the direction in which it came. So that bounce occurs whenever our multiplicity is an even number. So multiplicity is even. So that means it could be a 2, it could be a 4, it could be a 6, etc. We're going to try to always write everything with the lowest degree possible. So I will say here that our multiplicity is even, so I'm going to make that a 2. So now this translates when I go to modify my equation now that x plus 1 factor that we had to show that it bounces means that I have to put that even degree multiplicity along with that factor. let's turn over to the next one. For our next 0 here, we have 0, and we see that our graph just crosses right through. So a cross occurs when our when our degree or our multiplicity for one factor is going to be a 1. So it occurs when our multiplicity, I'm just going to abbreviate it, mult right here, multiplicity is equal to 1. So that means when I go to interpret my equation now, with that x factor that I had, I'm just going to put a 1 as its exponent. A last one here, we see that as we have a 2 that is a root, we have this, it crosses over the axis, but it does like a little shimmy shake, right? It does a little wiggle in here. And that's what I'm going to refer to it as. It's a little wiggle. So our little wiggle here occurs when our multiplicity is equal to 3. So when our factor is x minus 2, I'm going to put a little 3 there as our multiplicity, because that way it'll give us that little wiggle as it crosses over the x-axis. So a little check here. We know that we are looking at, if we add up all these multiplicities here, we have a 3, 4, 5, 6. We have a 6-degree polynomial. It's even, right? And our leading coefficient is positive. So just going back up to our chart from before, if we're looking at an even degree polynomial with a positive leading coefficient, we know that it ends up and up in both directions. Our function is approaching positive infinity in both directions as its end behavior. So that's kind of our little check right there. We know that our multiplicities have to be pretty accurate because it totals up to that end behavior that we're looking for. So let's take a look now at graphing a polynomial in factored form, because this is really where our goal is and what I'm going to ask you guys to be doing first. So we need to sketch a graph of a polynomial. I'm going to give it to you first in factored form. We'll eventually next week move into standard form. But as of right now, let's first translate our zeros. We know that this x minus 2 factor will have an x-intercept of 2. And because the multiplicity there is 3, that means we're going to have a little bit of a wiggle. Our x plus 5 factor has a 0 at -5. And because its multiplicity is a 2, that means we're going to have a bounce. Last factor, x plus 1, has an intercept. Oops, got that one wrong, sorry. Has an x-intercept of -1. And because the multiplicity there is a 1, that translates in just to a cross. All right, so we have kind of a game plan of what we want to do, but now we have to think about end behaviors. Does our graph start in the negative direction, or does it start in the positive direction? So if we total up all of our multiplicities, we get that this is an even degree polynomial to degree 6 with a negative leading coefficient. We have our negative right there. So if we have an even degree polynomial with a negative leading coefficient, that means our graph is going to start and stop in the negative direction. So I put the little arrows on there just to give myself some sort of guidance to go about. From there, I'm going to plot each of the points that I have. So I see the -5, I see 2, I see -1, and then I'm just going to start graphing. So I know I have to start in this negative region here. As I get to the -5, my graph has to bounce. So it's going to come up here, but then it's going to bounce and come right down. Now, we don't know how far it bounces down, and we're okay with that. That's why we're sketching the graphs. Okay? When you guys take later math classes, you'll be able to get more accurate graphs. As of right now, we're just doing kind of a rough sketch. So like I said, we're starting out in that negative direction because of the end behavior. As we get up to -5, we have to bounce back down off of the x-axis at the, it's a +2. So at the -1 is next. At the -1, we're told that we're going to cross. So we can cross now at the -1. Okay. Some quick math here, we can go ahead and figure out what our y-intercept is at least. If we plug 0 in every place that we see in x, we can see, looks like we're looking at positive 200, so it's way off our grid. So way off our grid there. We'll have to modify our graph to show it. At 2, we got to do a little shimmy shake. We need a little wiggle happening. So we got a little wiggle, and then again ending in our negative direction. Okay. Up here we can at least show the y-intercept, so we know what it's supposed to be. It's 0, 200. Okay. So again, going off of our graph, highlighting just the important stuff here, we know that we had to have a bounce right here. We know we had to have a cross right here, and then we knew we had to do a little wiggle for the 2. All right, let's look at one more for the day. One more, last part of the video. All right. For this one here, again, let's look at our roots. Don't forget about this one. When you guys did your homework last week, you forgot about the x and how that translates. So the x factor means that we have a root at 0. Its multiplicity is a 1, so that means that we're going to be looking at a cross. The x minus 6 root factor has a root of 6 because the multiplicity is 2. That means that it's going to bounce. The x minus 2 factor has a root of positive 2. Multiplicity is 1, which means it's going to again cross. And x plus 3 factor has a root of negative 3. Again, multiplicity is 1, so we're going to have a cross. Let's think now end behaviors. So if we total up all of our multiplicities here, we get that the degree of the polynomial is going to be 5, and our leading coefficient is positive. So if we're looking at an odd function that is positive, that means it's going to be starting in the negative direction and then ending in the positive direction. So we'll just kind of put the little hints to ourselves here as to where we're going to be starting and stopping our graphs. Next part, let's go ahead and put our zeros in place. So I see a 0, I see 6, I see a 2, and a negative 3. All right. So again, we know we're starting in the negative direction. Once we get to the negative 3, we're going to have to cross over it. So starting in the negative direction, I'm crossing at the negative 3. The next root that I get to is at 0, which again is going to be a cross. We can do some quick multiplication there to get our y-intercept, right? Because it's just 0, so we don't have to worry about trying to find another point. So once we get to the 0, we again know that we're going to cross. When we get to the 2, we again know that we are going to cross. We don't know how far down we go, and that's just okay. We got to be okay with just having a general sketch. From the 2, though, we know we have to come over to the 6, and that one's going to be a bounce. So once we get to the 6, we're going to bounce up. And hey, we ended in that positive direction, just like we had anticipated that we would with our end behaviors. So just going through it one more time, we knew we were starting in the negative direction because we were looking at a positive odd function. So we started out in the negative direction. We knew we crossed at negative 4, crossed at 0, crossed at 2, bounced at 6, and then ended again in that positive direction. All right. Thank you again for watching.